Today we're going to graph systems of equations. When you're graphing systems of equations, first of all, you need to understand what a system of an equation is. A system is when you have more than one equation to graph. So you guys have studied earlier today or in the past couple of days how to graph equations. When we graph equations right now, we want to solve for y, and we want to get it in what we call slope-intercept form. So slope-intercept form is when you have y equal to mx plus b, where m is your slope and b is your y-intercept. So we're going to solve for y if it's not already solved for us every time before we start to graph. If you have a system of equations, that means you are going to graph two things and you are going to see where the two cross to give your answer. All right, so let's start with number one. We have y equals x. It's already solved for y, so what we need to do is identify the slope. The slope is the number in front of x. And since the y-intercept is whatever coefficient is being added or subtracted without a variable, in this case, the y-intercept is 0. So if I go to graph this first line, I'm going to start at 0, 0. My slope is 1 over 1, so I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. Or starting at 0, I could go down 1, left 1, down 1, left 1. You need to graph about 3 points so you can make a decent line. But to be honest with you, graphing as many points as you can on that first one will be helpful because one of those points is going to be your answer. So let's go on to graphing the second line. The second line has a y-intercept of 4 and it's positive. So that means you're going to go on the y-axis and you're going to go up 4 and you're going to put a point. Your slope is always a fraction, and in this case, it's -3 over +1. So because the 3 is negative, from the point, which is 4 of your y-intercept, you're going to go down 3, right 1, down 3, right 1, and you're going to graph that second line. Your solution is the point where they both cross or what they both have in common. You need to list that point and state its x and its y value as your solution. So if the two lines cross, your solution is going to be the point of intersection. Remember, when you're naming a point, the first number is the x and the second number is the y. The x-axis is the horizontal line and the y-axis is the vertical line. So again, when you graph two lines, where they cross is the point of intersection, and that is your solution. What that means is if you plugged one in for x and one in for y, you would have an equation that's equal to each other. So let me show you that up here. Our original equation was y equals x. Well, if I plug in 1 for y and 1 for x, they're equal. On the blue equation, if I were to plug in 1 for y and 1 for x and do the math, I'd get -3 plus 4, which is 1, so they're equal. So a solution is the x and the y value that you plug into both equations to make it true. My next two examples are special cases, but the special cases don't happen too often. So most of the problems in your homework will be like number one. So let's look at number 2. On this one, your y-intercept is 2. So from the origin, you're going to go up 2. You always go up or down because that's your y-axis. And then your slope is rise 1, run 2 to the right. Plotting just 2 points probably isn't enough. So you need to go up 1, right 2 again. Or from the y-intercept, your slope could be -1 over -2. So you could go down 1, left 2. and then you connect the dots and make your line. The reason why I make a lot of dots on the first line is because the other line most of the time will cross it, and where it crosses is your solution. So it's easier to tell your solution. On the second example, y equals 1/2 x minus 1, your y-intercept is -1, and your slope is +1 over +2, so that's up 1 over 2 again. Up 1 over 2 again. You could also go down 1, left 2, because if you make both of those negative, 2 negatives make a +1/2 for a fraction. This is a special case because those two lines don't cross. What that means is that we have no solution. No solution means there's no point that they have in common. Now let's look at our last example. In the last example, we're going to graph, again, this 3 is negative, so we're going to start at -3 for our y-intercept. Our slope is 1/3 x, so we go up 1, right 3. Or we could go down 1, left 3. We graph our line. The second equation is not solved for y yet, so you can't start graphing until it's solved for y. So you have to divide by 3, and you get y equals x over 3 plus 1. If you rewrite that, x over 3 is the same thing as 1/3 x. So again, if I go to graph this one, I'm going to go to 1 for my y-intercept, and I'm going to go up 1 over 3, or down 1 and left 3. So I have a special case again. These two don't cross either. So again, my answer is no solution. I gave you no solution twice in this example because you will see that every once in a while, and that happens when the slope of the lines are the same. Parallel lines have the same slope and parallel lines don't cross. But again, when you do your homework, most of your lines will cross like number 1. So go ahead and do that assignment and email me if you have any questions.